Good morning, ma'am. Am I audible? Anyone please confirm, am I audible? Students, am I audible?
Yes, ma'am, you are.
No.
So what we were discussing in the previous class? Which topic we were discussing in the previous class, ma'am? Do you remember the topics? You've seen quality of service, right? So how the quality of service, how we'll be giving QoS support for real-time applications. That's the topic that we were discussing in the previous class, right? So I'll just share the screen and this. Whether my screen is visible, ma'am? Please confirm whether my screen is visible. Can anyone please confirm whether my screen is visible? Ria, thank you. In today's class, we'll be seeing the key components of router. The components, functionality of router and a switch, and also VLAN, virtual local area network. Okay. Okay. So now we'll see the components of the router. So what's the main component? What is the purpose of a router? Router, it is a networking device, right? So what is the purpose of a router? To forward the data, right? So forward the data between computers. So what's that? Even it will be acting as an intermediate so that it will be forwarding the data to the appropriate destination. So whatever the data packets they receive, they'll be analyzing the data packet. First, they'll be receiving the packet. They'll analyze the packet. So from the analyzing, they'll be finding the destination address. Okay. So with the help of a destination IP address, they'll forward the packet to the appropriate destination. Fine. This is the purpose of a router. So the entry point, the first entry point is the input port. Okay. So it is nothing but a physical link. It is a terminal which receives or it will be connected to another device from which it gets the packet. Okay. So it performs the link layer functions like error checking, framing. Okay. All those things will be performed by the input port. Okay. It will be extracting the packet and also it will send the packet to the processor. So the router will be having a processor, or else it will be having a switch fabric. Either it will be, if there is a processor, it will be sending the incoming packet to the processor, or else it will be sending the packet to the switch fabric. Okay. So based upon the forwarding table lookups, it will be deciding to which output port the packet has to be sent. Okay. So that will be taken care by the switch fabric. Okay. So it will be using the forwarding table. Fine. So you will be having multiple number of access. The lookups are there. Okay. So you can use DRAM for storing the forwarding table, and also SRAM, static RAM for storing the table. And also you have content addressable memory as well. So the faster lookup is the content addressable memory when compared to all these things. Okay. So forwarding table, it will be using the destination IP address. Already I've told you, it will extract the destination IP address. Based upon the destination IP address, it will be looking the data inside the forwarding table. Okay. And it will decide the best path. Okay. So how does it will be doing? The router will be doing a longest prefix match, right? So based upon the longest prefix match, it finds the closest match in the table. Okay. So quickly it will be doing. So those things has to be done very quickly. Okay. It should be fast, and also it should be efficient. Fine. So for that, we'll be using many algorithms in order to speed up the LPM process, that is longest prefix match process. Okay, so trie-based search, binary search, hash tables, anything can be used to uh, in order to check the entries in the forwarding table. Fine. The fastest memory is the extremely fast. If you want to extremely, the fastest lookups are DRAM. It is cheaper but also slower, and SRAM, it is faster when compared to DRAM. It is faster, and the fastest, if you want to say for the fastest extreme fastest for direct matching, then you have to go for content addressable memory. Okay, the next one, switching fabric. Switch fabric, it is the internal routing. It is the heart of the router. Okay, so it will be connecting the input port to the output port. So all the transfers of the data will be taken from the source port to the destination port inside the router. Okay, so it can be implemented using the bus, crossbar, or interconnection network. So into input ports, it will be receiving and processing the incoming data. And if I want to do the faster search, then I have to go for implementing CAM, okay, for LPM lookups. And switch fabric is the one which handles the internal data transfer between the ports. The memory and algorithms will be uh, very much important in order to speed up the routing process. Right? Now we'll see what is the purpose of an output port. So started the recording. Okay, output port. Output port is nothing but it is an exit point. Okay, it is an exit point for the packets. So the it will receive the packets from the switch fabric, which is there already inside the router. Okay, so all those things will be buffered. So they'll be storing the packets temporarily before transmission. So the link layer and also physical layer functions will be performed to prepare the packet for outgoing port, outgoing link. Okay, so this will include framing, error detection, modulation, everything will be taken for data link layer will be using framing. Physical layer will be doing error correction will be taken care by the data link layer. The physical layer, if there is certain modulations is required, that will be taken care by the physical layer. So outgoing link can be bidirectional. So it can be both send and receive the data packet. Okay. So output ports, it will prevent the packet loss by managing congestion before buffers. Okay. It will schedule packet transmission in all together for ensuring the quality of service. Okay. So many fairness algorithms are there for controlling the traffic. And also you have a routing processor. The routing processor, it is actually the brain. So it will run the routing protocol. So routing protocol, different protocols you would have studied, RIP, OSPF, right? Uh, PGP. So all these things will learn about the network paths. So it will maintain the routing table, okay, which stores the path information for every known destination, right? So it computes the forwarding table. So all these algorithms will be computing the routing table, and it will be stored inside. Okay, so which will be used by input ports. So though based upon the packet that has been received, it will be deciding the next hop for forwarding the packets. Okay, continuously the routing table will be updated. The past decisions will be changed based upon the network changes. So continuously it will be updating the routing table. So why routing processor is important here? So it helps the router to adapt dynamically to topological changes together with the failures as well as for the congestion. So it ensures packet always follow the most efficient path across the network. So it communicates with the routing processor in other routers to exchange the routing information. Fine. So this is actually the internal architecture of the router. Okay. So we have a control plane that is a software which is going to manage the routing process. Okay. So it will be running. You have two things. See, one is hardware, another one is software. So management control plane is a hardware and forwarding data plane, sorry, it is a software and forwarding data plane is a hardware. Okay. So the software is the one which will be running, which is the one uh, to run the algorithms, routing algorithms, responsible for running the routing algorithms. Okay. And also it will be updating the routing table based upon the dynamo, topological changes and also uncertainty. Okay. So it will be determining how the packets will be forwarded based upon the routing table. Okay. And you have a data plane, forwarding data plane, which is the hardware. So responsible for forwarding the packets, actual how the packets will be forwarded. Okay. So we have input port, switch fabric, and also output port. Okay. So what is the purpose of an input port? It will be receiving the packets. So see here, it will receive the packets from the physical link. Okay. So, and also it performs the link layer functionalities, error checking, framing, and all. And with the help of the routing table, forwarding table, it will be deciding the outgoing port. Okay. And it will be sending the packet to the switch fabric. So, what is the purpose of a switch fabric? It is a connector. It is a central connector, which is there inside the router. So, it will transfer the packets from the input port to the output port. So if this packet has to be sent to this outgoing port, that will be taken care by the switch fabric. Okay. So it will select the appropriate correct output port and it will be forwarding the packet. So it can be a crossbar, bus, interconnection networks. So in order to manage the traffic, any type of switching fabric you can use. Okay. What is the purpose of an output port? Output port, it will receive the packets from a switch fabric. Okay. So if many packets are there. So there will be a buffer. It will buffer the packets temporarily for managing the traffic. Okay. And also it also performs the link layer functionalities like error correction, framing, and physical layer functions like modulation. Okay. And it transfers a packet to the next router or even that could be an end device. It is a bidirectional link where it can receive the packet as well as it can send the packet. Fine. So routing processor, what is the purpose of a routing processor? It will be executing the routing protocols. The routing protocols, say for example, if I'm using PGP, it will route the routing table. It maintains the routing table based upon the algorithm and also it computes the forwarding table. Okay. So it informs the input router about the path decision. So this is the one which will be controlling the data plane. So from here, the control plane, that's the reason it is called as a control plane. It will be controlling and the data will be forwarded to the appropriate output board based upon the routing table. Fine. Any doubts? Do you have any doubts as of now? Any doubts, ma? 60 plus students are there. Only one response I'm getting. What about others? Are you there in the meeting? So now we'll see switching, the difference between filtering and forwarding. Okay. So what is switching? Switching, it is a function of a network switch, or even it could be a router. Okay. So how the data frames are processed and how it will be transformed, transferred across the network. That is the purpose of a switching, right? So what is filtering? There is two things. One is filtering, another one is forwarding. So filtering is nothing but deciding whether to drop or forward a packet. That is called as filtering. So it will decide whether to drop the packet or forward the packet. Okay. The switch is responsible for checking the destination MAC address. Okay. So it will be checking the destination MAC address of the incoming frame. So if the destination address is not there in the forwarding table, in that case, it will be invalid. The packet frame will be dropped. Okay. Not it will not forward it anywhere. So if it is valid, it will be moving the packet to the next step, which is called as forwarding. Okay. Forwarding is nothing but it is actually sending the packet to the correct output port. Okay, so here we'll be deciding whether to forward or drop the packet. Here actually we'll be sending the packet. Okay, sending the packet to the appropriate port, output port. Okay, the switch will be finding the destination MAC address. It will use the forwarding table or the routing table. So from that, it will check whether the data is there. So if it is there, it will be sending the packets. Okay, so if it is a switch, you know it is an intelligent device, right? So if switching table, forwarding table is empty, what your switch will do? Switch will broadcast in case of unknown destination. It will be broadcasting the packet. It will duplicate as many number of outgoing ports are there. So if it is a 8-port switch, so 7 packets will be duplicated, and for other than the incoming port, for rest of the ports, the packet will be forwarded. Okay, so that makes the switch an intelligent device. But if switch fails to learn new MAC address, what will happen? Continuously, it will flood the network. That is the main disadvantage of a switch as well. So you have to remember that. So what is filtering? Filtering is a decision phase, whether I have to forward the packet or whether I have to drop the packet. Forwarding is nothing but it is an action phase where should I send the packet. That will be determined by the forwarding routing table. So filtering and forwarding uh, together, it will we have to ensure efficient network traffic. Right? So switching, how the switch learns, how the switch filters and forwards, that we'll see. So switch routing table is nothing but it is the table which stores the mapping of the MAC address to the appropriate interfaces. Okay, so the forwarding table will help the switch to filter and forward the frames to the appropriate destination address. So each entry links, there will be a destination MAC address linked to it to the appropriate specific port number on the switch. Okay, now we'll see what is filtering and what is forwarding. So filtering is nothing but the switch will check if the destination MAC address is known. So if not, the frame will be either broadcasted or frame will be dropped. Okay, so that is filtering. So what is forwarding? Forwarding is if that is known, the switch sends the frame only to the appropriate port number. So in order to reduce the traffic, the forwarding will be taken care. Fine. So how the switches will learn the MAC address? So when a new frame arrives, so this is my switch. I'll take it as a 4-port switch. So port A, B, C, 1, 2, 3, 4. I'll name it as 1, 2, 3, 4. So 1, it is connected to, okay. So port number and the destination. Fine. So initially A is sending the packet. Okay. A is sending the packet to C. Fine. So it comes inside. Okay. Now it understands port number 1 is connected to A. By seeing this packet itself, it understands port number 1. Why? Because through the port number 1 only it receives the packet A, right? So A is packet. So it will update the routing table as from 1, A is connected. Now it will not know C, right? So if it is not knowing C, what it will do? It will just duplicate as many number of outgoing ports and it will broadcast the packet to all the uh, ports, outgoing ports. For it will broadcast to 2, 3 as well as to 4. So what B and D will do, it will just drop the packet. So what happens for C? C will accept the packet and it will be sending the acknowledgement. So when it is sending the acknowledgement, C will be the source address and A will be the destination address. So when it comes in, now the switch will understand port number 3 is connected to C. So what is A? It will again look into the forwarding table. One is A is connected to port number 1. So it will not forward, duplicate and forward the packets to all the outgoing ports. Instead, directly it will be forwarding the packet. So this is how it will be learning. Okay. So if it is a 4-port switch, it will update 2 as well as 4. So what is 2? 2 and this is what the destination. So it is just a 4-port switch. So if another packet is coming from A, in order to by including the MAC address as E. Okay. It is only the 4-port switch. It looks in it will make a lookup in the forwarding table. There is no match. It will just drop the packet. So this decision is called as filtering. So whether I have to drop or whether I have to forward. So how the switch will be learning the MAC address. So whenever the new frame arrives at the switch port, it will read the MAC address and it will verify in the routing table. So in the routing table, if there is no entry, it will just duplicate the packets and it will forward the packets. So whereby whenever it comes in, when the packet is sent by the appropriate machine, a corresponding port number and destination will be updated inside the routing table. So this is the way the switch will be learning which device is connected to which port. So this learning process is automatic and it is also dynamic. Okay. And also they are plug and play devices. Switch supports plug and play functionality. So no manual configuration is needed. So devices can simply connect it or simply it can be moved. The switch will learn and update its table accordingly. Fine. So now we'll see multiple simultaneous transmissions, how it is happening. So each host is having a direct dedicated connection to the switch. As you can see here, it is a 6-port switch, 1, 2, 3, 4, 5, and 6, A, B, C, A dash, B dash, C dash. Okay. So packet buffering will be done by the switch. So switch will be buffering the incoming packets. So it handles short burst of data efficiently. Okay. Packet will be temporarily stored. So in order to forward, uh, if already in the outgoing port or incoming port, if traffics are there, it will just uh, store the packets. Okay, in order to reduce the loss. So it is a full duplex communication. It supports full duplex communication. What do you mean by full duplex? So each connection will be full duplex. So on the way we can send and receive the packet at the same time. Okay. So Ethernet here I say it is Ethernet is used. Okay. So without collision detection, Ethernet is used here. So each link has its own collision domain. Okay. Separate connections are there. So it can isolate the traffic between the devices. So simultaneous transmission is supported. Why? Because uh, full duplex communication is given here. I'll take in this example, A wants to communicate to A dash. Likewise, B wants to communicate to B dash. Okay. So how the simultaneous transmission happens. So both transmissions are happening at the same time. A wants to communicate the packet to A dash and B wants to send the packet to B dash. Okay. So the same time without the interference. So how it is happening? The switch will be maintaining the switching table. This is actually the forwarding table, MAC address table or the forwarding table in order to map the address to the interfaces. Okay. And also it will hold TTL, that is time to loop. So it is used to um, uh, have the stale entries, age out the stale entries, we'll be updating the TTL. Okay. So when, since it is a full duplex communication, switch is also having the buffers. A, whenever A is sending the packet and B is sending the packet, the switch will take the packet and it will buffer the packets temporarily. Okay. So it will update from interface 1, A is connected, and in interface 2, B is connected. Fine. So now it will not know to which packet the packets are being, A dash is connected to which port number and B dash is connected to which port number. That is not known by the switch. So what the switch will do, it will duplicate the packets and it will first it will duplicate A dash and it will forward the packets to all the outgoing ports. Okay. Likewise, B dash will be taken and it will be duplicated and it will be forwarding the packets to all the destinations. Whenever it is sending an acknowledgement, A dash and B dash entries will be updated. So A dash is connected to port number 4 and B dash is connected to port number. Since it is a full duplex communication, at the same time it can send and receive the packets. Okay. So this is how the collision-free communication will happen. Okay. It supports multiple simultaneous full duplex communication transmissions to improve the speed and reliability. And also it is self-learning. So it will update the entries by learning whenever it comes, packets are coming from the port numbers. Fine. Any doubts? Any doubts, ma? Now we'll see forwarding in switches. So forwarding in switches and collision domain, switch forwarding table, switch will maintain a forwarding table, which is called as a MAC address table. So for each and every port number interface, the MAC address will be assigned to it. Okay, so the destination MAC address lookup will happen. So when a frame arrives, the switch will check the destination MAC address and also it looks into the forwarding table. So if the MAC address is found, the switch will be forwarding the frame to the appropriate output interface. Okay, so if the MAC address is not found, what the switch will do, it will simply flood the frame to all the other outgoing port numbers except the one it is arrived. For rest of the port numbers, it will be forwarding the packet. So the frame will be reaching the destination if the switch is not learned that appropriate uh, destination is connected to which port number. Okay. But here there is an advantage. So if the switch is not updating, it is not learning the, if it fails to learn the new MAC address, what will happen? Continuously, it will flood the network. Right? So the collision domain is a network sector. If I want to say collision domain where the data collisions will occur, that is called as collision domain. So happens when two devices try to send the frame at the same time on a shared medium, right? So in the shared Ethernet, all the devices will have a large collision domain. But in the switch will be breaking up the collision domain. So one per port. So this is how it will be preventing the collisions. So switch will be using the forwarding table and also if there is no entry, it will do the flooding. Collision domains will be minimized. Why? Because for each and every port, one collision, one per port, the collision domain will be one port. So it decreases the collision. Okay. So forwarding in switches. So forwarding in the switches, forwarding switches will be examining the destination MAC address, right? If the address is known, it will send the packet. If it is not known, it will broadcast the packet, flood the packet. So broadcast domain is nothing but it is a group of device which will be receiving the broadcast frame, which is sent by one member in a group. So broadcast are sent at the data link layer. So the layer 2 with the help of a MAC address uh, FF colon FF colon FF colon FF. So this represents if the destination address is this MAC address, it is actually the broadcast address. So it will be sending the packet to all other outgoing ports. So too many devices in the broadcast domain, what will happen? There will be performance issues. So managing broadcast domain will help to improve the network segmentation. Fine. So the layer 2 switch will be creating a collision domain as well. So collision domain, already we have seen there is a difference between a collision domain and broadcast domain. So the layer 2 switches will be creating a separate collision domain for each and every port number. In the previous slide itself, I've told you. So each device will be connected to a different port. So it will not collide with anything. But all the ports on the switch will be a part of the same broadcast domain by default. So in that case, it comes under the broadcast domain. That's the difference between a collision domain and broadcast domain. So how to separate the broadcast domain? So the routers will be separating the broadcast domain. Okay. So for that, we'll be going for virtual LANs. So virtual LANs on switches can divide a single switch into multiple broadcast domain. So in order to enhance the network performance, we need to isolate the collision. So collision can be isolated by based upon the port number, but still we need to limit the broadcast domain. So with the help of the routers and VLANs, we can segment the broadcast. Okay, so we'll see that. So this is an example, high level institutional network. Okay, so the core of the network, there will be a core switch. Okay, so this is actually the core switch. Okay, that connects different departments. Here, 3 departments are connected: electrical engineering, computer science, and computer engineering is connected to the core switch. Okay, so and even it is connected to the external internet as well as the servers. Fine. So it is a high speed switch which supports 1 Gbps of data capacity to ensure the traffic flow across the networks are done in a smooth way. Okay, so 3 departments are connected. So which is of which uses the fiber optic cables that supports 100 Mbps. Fine, electrical engineering, computer science, and computer engineering. So each department will be using a local switch here. So this is how it will be limiting the broadcast domain. So here, this switch limits the broadcast domain here, this one and this one. Fine. So these switches support a mixture of links. It can be of 10 Mbps, 1 Gbps, 100 Mbps, category 5 cable, okay, coaxial cable. So the servers will be supporting the web server, mail server supports 1 Gbps. Okay, so there is an internet connectivity in order to connect to the external network. Okay, the institution network is connected to the external network with the help of uh, the router that with the help of the edge router. Right? So what are the issues with switch hierarchy in the institutional network? So we have seen this is an institutional network. It is connected to 3 different departments, 2 servers, and 1 edge router. Fine. So what are the issues with the switch hierarchy? So lack of the first one, lack of traffic isolation for the broadcast. All the devices in a single broadcast domain will be receiving the broadcast traffic. Okay, so definitely it will lead to congestion and unnecessary load on all the connected routers. Okay, all the connected hosts. So the routers has to separate the broadcast domain. So the layer 2 switch can also provide the support with the help of virtual LANs, but we can go for the routers. Okay, the first one. And also the second one, inefficient use of a switch. So the more departments, if more departments are added, more first level switches are required. Okay, it increases the cost, space, power, everything is increased. Okay, without traffic isolation, again there will be a problem with the broadcast domain. Again there will be a problem with the performance. Okay, and also we have to manage the users across the different departments. Okay, and also it is hard to manage the users. So when one person from electrical department, he's shifted to computer science, or from computer science department, he's shifted to computer engineering, move between the departments, that is very hard to manage. Okay, so but if that person is belonging to multiple departments, there is also another problem. So manual configuration of switch ports is required, and also access rights is required, which is time consuming. Instead of doing all these things, we can go for the best solution is one of the solution is virtual LAN. Okay, it will logically separate the departments. So even if I'm using a single physical switch, it logically separates the department with a centralized user authentication. A dynamic assignment can be done. Manual configuration is not required. Dynamically, we can do it. Okay. So, so in order to, these are the three main problems. It can be rectified with the help of a virtual LAN. The solution is virtual LAN. So what is virtual LAN? So virtual LAN is nothing but it is logically, physically, it will be a single network, local area network, but logically, it will be segmented into multiple networks. Okay, using software, not with the help of physical connection. Okay, so VLAN, it will be grouping the devices based upon the functionality or based upon the department or based upon the project, not the physical location. Okay, so the logical segmentation will be done over the physical layout. So the devices in the same VLAN can be across multiple switches or can be across multiple buildings. Okay, so finance departments can be in the first floor, second floor, third floor. Okay, that can be connected to the virtual. So even they are in different rooms, different buildings, it can be connected. So virtual switches will be, we'll be using virtual switches instead of physical switches. So VLAN, they allow to split the physical switch into multiple virtual switches. Okay, so each VLAN will be acting like a isolated network. So thereby it will be preventing the broadcast domain. Okay, so the traffic isolation will be done. So only one device within the same VLAN we can communicate directly. So devices in different VLANs, they cannot talk to each other directly, but the devices within the same VLAN, they can communicate directly. Okay, so in order to communicate between virtual LANs, two different virtual LANs, the traffic must pass through a router or a layer 3 switch. Fine. So if these are the port numbers. Fine. So it is a 12 port switch. Fine. So I'm taking these two things separately, and these are connected to systems. I represent this to be computer science department, and these things are connected. So I represent this as electrical department. Fine. So these two things can be connected to a router. Okay. So systems within the computer science engineering department, they can communicate directly. Okay. This communication is supported. Okay. But the computer science engineering department, a system in the computer science engineering department cannot directly communicate with the system, the host in the electrical engineering department. So in order to do that, so it should be routed with the help of a router. Okay. So this is how two VLANs can communicate. Okay. With the help of a router. That's the reason it should be connected via a router. Fine. It should pass through a router, or even it can be a layer 3 switch. Inter VLAN routing can be supported with the help of a layer 3 switch. Fine. Any doubts, ma? Any doubts? 70 students are there. No one is responding. Do you have any doubts? Only Parul is connected.
No, ma'am.
So broadcast domain segmentation. So VLANs, they'll be creating separate broadcast domain. Okay, so within the same physical network. So it will be acting as a mini network. The broadcast can be limited to the corresponding VLAN. Okay, so logical segmentation is supported here. So logical segmentation is nothing but VLANs, they allow networks to be grouped logically. Okay, so instead of physical connection, it will be logically say grouped. Okay, all the HR systems can be in VLAN 20. Okay, even they are connected to a same switch or a different switch. So in this example, a same switch is connected. Only one switch is there. So that has been categorized into two different departments. Okay, so the VLAN groups the devices based upon the functionality or based upon the application, based upon the team, based upon the department. Okay, so how they are connected. In that way, it will not group based upon certain criteria, it will be grouping. Okay, so centralized policy and enforcement can be done. Fine. So the workstation can be a part of specific VLAN, even if it moves from one switch to another switch or one physically, even if it is moving from a location to another location, that can be connected. So VLAN gives you the flexibility of moving the systems, even that will be connected to the same VLAN. Okay, so it is based upon the port, MAC address or authentication. So easy to manage. So it will limit the broadcast traffic, it enhances the security, it provides a network segment, and also it supports user mobility. Right? So workstation and VLAN can only communicate with other devices within the same VLAN. Already I've told you, right? So if I have two departments, these two systems can communicate directly, right? And these two things can be they can communicate directly, okay? But a system in this department, it cannot communicate with the system in this department, okay? So if two VLANs, if two systems on different VLANs, they want to communicate in that sense, it should be passed through the router. Okay, so inter VLAN communication is not allowed. Okay, so through a router or layer 3 device only, we can route the traffic. Okay, so it gives you security and also it gives you isolation. Okay, it isolates the sensitive data and also it prevents the unauthorized access. And also together with that, it limits the broadcast traffic, right? So this is how the things are. So two different VLANs, they cannot talk to each other. So with the help of a router, they can communicate with each other. That's it. Fine. So VLAN configuration, VLAN, a single switch can support two or more VLANs. Fine. In the previously I've told you with an example. Okay, we have discussed an example. So each VLAN functions as a logical network. Okay, so even it is connected to the same switch, a single switch, you can categorize into three different departments. Okay, so physically we cannot categorize, even they are physically connected to the same switch, they'll be logically separated. Okay, so it supports network growth without the physical wires, isolations, security, unauthorized access, monitoring, configuration, everything can be done. So Intel VLAN communication, already we have discussed, it should pass through a router. No two direct host or devices can connect or can communicate directly with each other on different VLANs. Okay. So for that, we need edge ports. So ports where user devices are connected, those ports are called as edge ports. Okay. So each edge port will be assigned a specific VLAN. So switch will behave like multiple virtual switches. Okay. It will forward the traffic only within the VLAN. It will does not bridge the traffic across VLANs. Uh, so in order to maintain the broadcast domain, it will be doing that. Okay. So if two different systems on two different VLANs, if they want to communicate, they have to pass through a router. Fine. So this is an example, represents, this is a single switch, right? But there are two VLANs configured. So VLAN X and VLAN Y. The orange colored are X and green color are Y, connected to Y device, Y network. Okay. All the devices are physically here. It is connected to the same switch, but logically it is segmented. Right? So the devices here, they can communicate with each other directly. Here, these three systems can communicate directly, but no system from X cannot communicate with Y directly. Okay, no traffic exchange is supported between VLAN X and VLAN Y directly. So it has to route through a uh, router. Okay, with the help of a router or layer 3 switch, that should be done. Okay, so it will be separating the broadcast domain within the same switch. Fine. So this is an example of local VLAN configuration. Only one physical switch, it will be acting like a two virtual switches, VLAN X and VLAN Y. Logically, it is segmented. Okay. So each and every group of systems on the same network, they can directly communicate. No two systems from a different VLAN communicate. They cannot directly communicate with each other. Fine. So traditional LAN segmentation and VLAN segmentation is provided here. Okay. So how the physical grouping is done? So the devices will be grouped on the physical location. Okay. Floors, buildings. Okay. In this example, we'll take floor 1, floor 2, and floor 3. Okay. Floor 1 is LAN 1, floor 2 supports LAN 2, and floor 3, there is a local area network 3. Okay. There is a shared up. So these are the shared up. This will be supporting the broadcast domain. So why a router is required? Communication between the LANs must pass through a router. So if this system wants to communicate with this system, then with the help of the router, the data transmission is supported. Okay. So here changing the network requires more cables, right? Moving cables. So it will not give you scalability. Okay. So broadcast traffic from one device will be affecting the entire LAN. Fine. That's the reason we'll be going for VLAN segmentation. So logical grouping. Here, even if these three systems are different floors, are there in different floors, they are same network. Okay, it is connected to the same network. I'll take it as X, Y, and Z. So these three systems are in different floors, right? But they are connected. So here to a single switch, all three different network systems are connected. Again, in this switch, all the three systems are connected. So where it will be logically segmented into three different networks. Okay, so devices will be grouped on the functionality. Fine. So regardless of physical location, they'll be grouped upon the functionality. So ports will be assigned to the VLAN. That's how. So I say VLAN 10, VLAN 10, and VLAN 10. The second is 20. I'm assigning 20. Okay. So for the third one, I'm assigning 30. Okay. So ports on the switch will be configured in VLAN 1, VLAN 2, and VLAN 3. So this will be creating a separate broadcast domain. So with the help of a router, we can route the traffic between the VLANs. Okay, better network security management performance, everything can be done. So in traditional LAN segmentation, devices will be grouped by the location. Okay, so each floor, it forms a separate network with the help of a shared hubs. So communication between the floors can be supported with the help of a router. So reconfiguring it is very critical. So that's the reason we'll be going for VLAN segmentation. So grouping can be based upon the logical needs, not the physical layout. So each VLAN here, it will be behaving like a different or the separate network. Okay. So even if it is on the same switch, logically it will be separated. So it makes VLANs more flexible, secure, and also scalability, security, everything is provided when compared to the traditional LAN segmentation. Fine. So now we'll see the broadcast domains with VLANs and routers. Okay, so without VLANs and here with VLANs. So each department here, engineering, marketing, and sales, three departments are there. So three departments are connected to separate switches. Okay, switch 1, switch 2, switch 3. So these switches are connected to a router, okay, using a different fast Ethernet ports, 0, 1, and 2. So every department, they'll be having a separate IP network, right? So each switch will be creating a broadcast domain. So here, this is the broadcast domain. Here, this is the broadcast domain. And for this is the broadcast domain. So they require more hardware. Multiple switches are required. It is not that much easily we cannot scale. So adding more departments, more number of ports are there required, and more number of switches are there required. So uh, the cost will be higher. So that's the reason we'll be going for VLAN. So single switch here, without a multiple switch, I have only a single switch. Single switch is configured for different multiple VLANs. So this is engineering, marketing, and sales. One switch is connected to, logically it is segmented into three different departments. So devices in each department, logically they'll be grouped into VLANs, appropriate the corresponding VLANs. So they can communicate with them directly. So if they want to communicate a system which is connected to a different VLAN, it should pass through a router. So router enables inter-VLAN routing, or even with the help of a trunk link, it can be extended. Fine. So here each department requires own switch and also network connection. Okay, so multiple broadcast domain will be there. But VLAN departments can be segmented logically. So with a single switch, it can be logically separated into multiple VLANs. Okay, based upon the post configuration, separate VLANs can be like engineering, marketing, sales can be given. So it will maintain its own broadcast domain. Fine. Now we'll see how the VLAN can be configured on a single switch. So the switch will, here it is a 16 port switch, okay, which are numbered from 1 to 16. Switch has 16 ports, okay. So port 2 to 8, they are assigned to electrical engineering, and 9 to 15, they are connected to computer science VLAN. Two VLANs are there, electrical engineering, computer science. So they form a logical network within the same physical switch. Okay, so VLAN port will be port assignment can be done. So each port will be manually configured to a member of a physical specific appropriate VLAN, right? So say for example, if I'm taking port 3. So port 3, it is electrical engineering. Okay, what about port 10? Port 10 is a computer science engineering, right? So each and every port number will be manually configured to the appropriate VLAN. The switch will be maintaining the internal port to VLAN mapping table as well. So if it is required, it can have an internal port to VLAN. So this table will have the Ethernet frames that can be forwarded to the ports within the same VLAN. So that mapping will be done here. Okay. So the devices on port 2 to 8 will be of one broadcast domain, and from devices from 9 to 15 will be on separate broadcast domain. Okay. So this is how the traffic isolation will be done. Okay. So even though devices are connected to the same physical switch, communication is not directly supported from port 8 to port 9. Why? Because port 8 is connected to electrical engineering and port 9 is connected to computer science engineering. So this can be supported with the help of a router. Fine. Any doubts? Any doubts, ma? Students, do you have any doubts? Do you have any doubts?
No, ma'am.
What about others? Simply you'll be connected and you'll be leave the. How many times you want to ask for getting the answer? Now we'll see. VLAN configuration. It is a port-based configuration. Just now we have discussed, right? A single physical switch can be logically dividing the network into two virtual switch. It will be like a two virtual switches which will be configured to different VLANs. Okay. So in this example, VLAN 1 is electrical engineering and VLAN 2 is computer science engineering. 1 to 8 is connected to electrical engineering and 9 to 15 is connected to computer science engineering. Okay. So single physical switch here is connected as a logically it is separated. My multiple isolations are done here. Okay, it is a port-based VLAN configuration. So ports will be manually assigned to VLAN with the help of a switch software. Okay, so frames on port 1 to 8, they can forward the packets, they can communicate with each other. As well as from 9 to 16, they can communicate with each other. Okay, logical separation is done. So two different departments are configured here. So no two systems from different departments, they cannot communicate with directly. Why? Because the broadcast and also it will be limiting the broadcast domain. So say for example, if switch 2 is forwarding a packet uh, to the they want to broadcast the packet to the entire electrical engineering. It will be broadcasted only to all these devices, not to any one of the system in the computer science engineering. So the packets will be duplicated and it will be forwarded to 1 to 8 other than 2. Okay, so this is how it will be limiting the broadcast domain. Fine. So without VLANs, all the ports can forward and receive all the frames. Okay. So unless manual restriction is there. But with the help of VLANs, the switch maintains separate forwarding databases. And also they'll be limiting the broadcasting domain. So no two systems within the different networks, they can communicate with each other directly. So for that, they need a router. So how the manual configuration can be done? So manual configuration, say for example, I want to say a VLAN 10. Okay, so switch configuration. I want to say VLAN 10. So what is the name? So what's the name? Configuring VLAN. What's the name? I say the name is electrical engineering. Fine. VLAN and 10 is electrical engineering. So if I want to say uh, computer science for 20, I'll again write switch configuration VLAN 20 and the name is computer science engineering and I'll be exiting. Okay, so how to configure the interfaces? So I'll be saying configuration, the interface range 1 to 8. Okay, so mode access will be provided and also the switch port access will be given to VLAN 10. For computer science engineering, it will be from 9 to 15. Okay, so mode access, switch port mode access and VLAN configuration should be done for VLAN 20. Okay, now we'll see the MAC-based VLAN configuration, how it can be done. So MAC-based VLAN will be assigning users to VLANs based upon the unique MAC address. Okay, rather than physical port number, that can be done with the help of a MAC address. Okay, so this will be useful when the users frequently they change the ports. Okay, so MAC address will be stored in the MAC address table. So with the help of the mapping, we can do the mapping to the appropriate VLANs. So two VLANs are here. So this is VLAN 1, VLAN 2. Okay. So VLANs are associated with the MAC address. Instead of saying the port number, we are grouped based upon, it has been grouped based upon the MAC address. So this is VLAN 1 and this is VLAN 2. Okay. So every switch will be maintaining the MAC address table. So that's how it will be tracking the VLAN, which are the systems based upon the MAC address, it will be deciding this device is belonging to VLAN 10 and this belongs to VLAN 20. Okay, So switches exchange MAC tables across the network. So table exchange is done here. So based upon that, administrative overhead is reduced. The tables will be updated and synchronized continuously so that filtering performance can be upgraded. So this is how the assignment can be done based upon the MAC address. So instead of port numbers, we can go with assigning the MAC address. So flexibility is also provided via when one system having the MAC address from here, it is moved to a different switch. From this switch, it is configured to this switch. Okay, so even it can be connected to VLAN 1. Okay, so by based upon the MAC address. Fine. So the table maintenance will not be a problem. Why? Because the table exchange will be done between the switches, and also table-based process can be implemented. Even if the switch two systems on different two VLANs they want to communicate, we can introduce a router so that they can easily communicate with each other. Fine. So VLAN operation, logically how it is segmenting a physical network into multiple broadcast domain. So each VLAN, it is corresponding to a particular segment, subnet, right? So this is the address. Fine. So each device in the same VLAN, they'll be sharing the same IP, right? Within the subnet. So two VLANs are there, VLAN 1 and VLAN 2. So this is VLAN 1 and this is VLAN 2. Okay, so VLAN 1 supports 172.30.1.x and VLAN 2 supports 172.30.2.x. Right? So 1, it is for 1.x is VLAN 1 and 2.x is VLAN 2. Fine. So this is how different subnets will be mapped to different VLANs. So this will be assigned to switch ports, not the host directly. Fine. So the switch 1, port 1, port 3, port 5, as you can see here. Sorry, port 1, port 3, port 6 are connected to VLAN 1. Okay. Port 2, port 4, port 5 are connected to VLAN 2. Okay. So host connected to a specific port number, it automatically becomes a part of a VLAN assigned to that port number, right? So device can be configured with the help of an IP address so that it can, based upon the port number, we can we can distinguish between the manually we can configure the port number to the VLAN. Okay, so VLAN one uses 172.30.1.x and VLAN 2 uses 172.30.2.x. So single switch is used, but logically it is configured into two networks, local area networks. Right? So how it separates the broadcast domain within the network. So VLAN 1 and VLAN 2, they have two separate domains, broadcast domains. You all know that. Without the LAN, the broadcast, how the broadcast will be done, it will be looking like an ARP request. Okay. So a broadcast, if I'm doing an ARP request, what is the purpose of an ARP? Address resolution protocol, in order to get the IP address, MAC to IP and IP to MAC, right? So ARP request, what will happen? It will flood the entire switch and it will reach all the subnets. So in from a switch, if one system is giving a ARP request, it will be flooded to all the port numbers in this switch. That is the problem, right? It will reach all the host connected to the same switch. What will happen with the VLAN? The RP request, it will be sending only to the port number or the port numbers which are configured to the VLAN 1. Why? Because so this system is sending a request. So it is configured to VLAN 1. So it will be broadcasted to port number 3 and also to the port number 6. Why? Because 3 and 6 are connected, are part of VLAN 1. It will not be forwarded to 2, 4 and 5. So this is how it will be limiting the broadcast domain. So the switch will be forwarding this broadcast only to VLAN 1 ports, that is 3 and 6. Okay. So even rest of the devices connected to the same switch, it will not forward to rest of the switches, rest of the ports. Why? Because these ports are belonging to the different VLAN. So whatever the ports that are configured for VLAN 1, for those port numbers only, it will be broadcasting. Right? Now we'll see VLAN operation. So every switch port can be assigned to a different VLAN. So logical segmentation can be done if the devices are connected to the same physical switch. Okay. And also the broadcast sharing will be within the VLAN. So ports in the same VLAN will have a single broadcast domain. Okay. So just now we have seen. And also broadcast isolation can be done across the VLANs. So ports in different VLANs, they will not receive any broadcast from other VLANs. So traffic isolation can be given so that we can ensure the security, and unnecessary broadcast can be limited, right? So VLAN operation on a switch. So we can separate bridging tables for VLAN. Okay. So the switch will maintain the bridging table. So for each and every VLAN, there will be independent bridging table. Okay, that is MAC address table. So we can ensure isolation of traffic between the VLANs by maintaining this table. Okay, so the frame can be handled based upon the VLAN membership. So when the frame arrives, okay, so for example, if frame arrives on the port number 1 that belongs to VLAN 1, the switch only will be searching the VLAN 1 bridging table. Okay. So if the source MAC address is not already present in the table, the switch will be adding its entry and it will be bridging the table. It will forward the packet to the appropriate port numbers which are part of the same VLAN. Okay. Not even it will flood the packet to entire switch. Instead of that, VLAN, what are the ports manually it is configured to VLAN 1? For those only it will be forwarding. Okay, if the destination address is unknown. So the frame will be flooded only within that VLAN. So the learning and forwarding decisions will be restricted to the VLAN alone. Okay, so strict broadcast domain can be provided. Okay, what about the bandwidth and management? So traditional shared network, all the users will share the same bandwidth. Okay, so more users, the bandwidth will be reduced per user, network congestion will happen, performance degradation will happen. Okay, but what is the advantage of VLAN? So it will improve the bandwidth. Why? Because VLAN, it is logically segmented into a network. So dedicated bandwidth can be given for each VLAN. So the users can experience the better performance. It reduces the collision when compared to the shared network. Okay, so the default management VLAN, by default, every switch port can be managed to the or mapped to the particular VLAN, management VLAN that belongs to the management VLAN. Okay, so the management VLAN is always VLAN 1, which cannot be deleted. Okay, so port can be reassigned to alternate VLANs based upon the network design. So logical separations will also be easy. Security, resource utilization, everything will be efficient in this case, right? So we'll see the port membership. So port-based membership. So when a device connect to a network, it will inherit the VLAN membership of the switch port, which is attached to it. Okay, so no manual VLAN configuration is required on that device. Okay, the default VLAN is VLAN 1. So every switch port is by default assigned to VLAN 1. So VLAN 1 is the management VLAN and it cannot be deleted. Okay, so the network administrators, they can reassign the ports to alternative VLANs as per the network design. Fine. So logical segmentation will be improved here. Fine. So how to span multiple switches? So spanning multiple switches So port to bit, traditional way of spanning is based upon port to port VLAN connections. Okay, so we can configure the port on each switch for the same VLAN, and physically we can connect them. Okay, so in this example, port 2 on switch 1, as well as uh, port 16 and port 1. Two switches are there. Port to port VLAN connections can be given. So port 16 is connected to port 16 and switch 1 is connected to port 1 on switch 2. So it will be wasting ports and it does not scale up when many VLANs are required. So instead of that, we can go for a trunk link, VLAN trunking. Okay. So physical link here can be connected to multiple VLAN simultaneously. Okay, so VLAN tagging can be added to the Ethernet frames so that it can identify the VLAN to which VLAN the frame is provided. Okay, or it is sent. Okay, a single, if I want to add multiple switches, a trunk link can be provided. Okay, so if I want to add more number of switches, a trunk link is provided, which will be carrying the tag information to identify to which VLAN we are sending the packets. Okay, so here two networks are there, and here as well we have two networks. Okay, with the help of a VLAN tag information, we can identify to which VLAN we are sending the packets. Okay, so electrical engineering department uses 2 to 8 and 9 to 16. It is used for computer science engineering. Right, so both VLANs will be sharing one trunk link. That is 16 is connected to 1. Okay, which reduces cable and also the port usage. Fine. So here two ports are connected. 1 to 8 is connected as well as 1 to 16 is connected. So multiple ports are wasted here. Okay. So but here one trunk link. Basically, if you want to connect it to different departments, this is this is network 1 and this is network 2. Okay. So two things are required. Multiple ports are wasted here. But here with the help of a trunk link, we can share the information. Two VLANs can be connected. With the help of a tag information, we can identify to which VLAN we are sending the packets. Okay. So how spanning across multiple switches is done here. So traffic exchange between the switches, two switches, they can exchange traffic from one or more VLANs. That can be done. So VLANs can span multiple switches. They can connect devices in the same VLAN across different physical switches. Okay. So for that, we need a trunk link. Okay. So inner switch links will be configured as a trunk link. So the trunk link will carry frames from all VLANs. Okay. So with the help of VLAN tagging. So VLAN tagging, each Ethernet frame, uh, it can be connected with the help of a trunk link. So trunk link, they carry VLAN tag. With the help of this VLAN tag, we can identify VLAN ID. So to which VLAN we are sending the frame. So that frame belongs to which VLAN that can be identified with the help of a VLAN tag. So VLAN trunking, we can scale up the network by adding multiple number of switches. So it reduces the need of multiple physical connections. Okay. And also with the help of a, we are minimizing the ports which are connected. So it helps us to improve the performance as well as reduce the cost. Right? So this is the example how the VLANs are connected across the switches with the help of VLAN tagging. Okay. So VLAN tagging, what is the purpose of doing that? So VLAN tagging is used when physical link, that is trunk link, carry the traffic for multiple VLANs between the switches, right? So without VLAN tagging, what will happen? Separate physical links are required. So see here. So in the previous example, 16 is connected to 1, okay, and also 2 is connected to 8, right? So multiple ports will be wasted here. So two different networks will be here and here, okay. So for connecting those things, multiple ports will be wasted, fine. So uh, separate links required for VLAN 1 and another one for VLAN 2, right? We'll be wasting the ports, we'll be wasting the cables, and also it will be very difficult to scale up. So instead of that, we can go for VLAN tagging. So VLAN tagging, only one link is, two ports are enough. Okay, single trunk link is enough to carry the traffic for both the VLANs, multiple VLANs. Okay, so Ethernet frames will be tagged with a VLAN ID. Okay, so to identify to which VLAN we are sending the frames. Okay, so it reduces the cabling. It we can scale up. Okay, scaling can be very easy across multiple switches. We can add up multiple switches whenever it is required. Right? This is how we'll be forwarding between the VLANs. So see here. So already I've told you two systems on the different VLANs, they cannot communicate with directly. Okay. So port number 7 is connected to electrical engineering and port number 11 is connected to computer science engineering. They want to communicate with each other. Okay. So it cannot be done directly, right? So VLAN logically it separates the switch ports. Okay, so no two devices on two different VLANs they can communicate directly, right? So it belongs to isolated traffic, right? So one, two, four, five, six, seven, eight, all these things belongs to the electrical engineering, and 9 to 16 they belong to VLAN, second VLAN, VLAN 2. Fine. So forwarding between the VLANs, they require a router. Okay. So all they have separate layer 2 domains. Forwarding the traffic between VLANs, it is not possible without a router. So inter VLAN routing is required. Okay. So vendors will be providing with the help of routing or layer 3 switch. Okay. So layer 3 switches or multi-layer switch, or even you can go for router for inter VLAN routing. Okay. So here we have two VLANs. Okay. So blue are connected to VLAN, I'll say VLAN 10, and yellow are connected to VLAN 20. Right. So if 7 want to connect, communicate, if 7 wishes to communicate with 11, definitely it has to pass through a router. Okay. So if two switches, if they are two different switches, we need a trunk link. Okay. So what is the purpose of trunking? Trunk port will be configured on a switch to carry the traffic for multiple VLANs, right? So the trunk link will be connecting switches, or it will be we'll be connecting the switch to a router for inter VLAN communication. So the switch will determine the VLAN, okay, to which VLAN we are sending. So VLAN tag information, it is a 4-byte information, okay, which is of 32 bits in length, okay. In order to identify, we'll be adding the informations like a MAC address, Ethernet field, everything will be added. The tag carries the VLAN ID, right? So 32-bit, that is 4-byte tag will increase the Ethernet frame size. So obviously the frame size will be increased from 1518 bytes. It will be increased to 1522 bytes. Okay, 4 bytes will be added. Okay, so MTU will be increased. Maximum transmission unit will also increase in order to accommodate the 4 extra bits. Okay, without tagging, multiple ports are required. So with tagging, the one link will carry the traffic for multiple VLANs. Right? So this is an example for VLAN trunking. Multiple VLANs, they share a single physical link between the switches. Right? So see here, a single port number on 2 switches, they carry multiple frames, which is belonging to 2 different VLANs. Okay, so VLANs ensure consistency across multiple switches. Okay, so VLAN X on one switch can communicate with VLAN X on another switch. Okay, or even VLAN X, a host which is connected on VLAN X on one switch can communicate with a host on VLAN Y, which is connected to a different switch. Okay, so for that we need a VLAN tagging. So VLAN tagging with the help of 32-bit, that is 4-byte information, we'll be doing that. So it reduces the cabling and also it reduces the number of ports. Fine. Now, check it out and let me know whether the quiz is enabled. Or whether the quiz is scheduled. Can you access the quiz? Yes. Okay. Complete the quiz then. Few more slides are there. We'll discuss in the next class. Complete the quiz.
Okay, ma'am.
Please don't leave the meeting. Complete the quiz, post it in the chat box, and then leave the meeting. I said don't leave the meeting. Complete the quiz, post it in the chat box, and then leave. Yeah. Okay. What about others? Done. Okay. Completed. Thank you, ma'am. Okay. It's taking a few minutes, not 10. But from the next class onwards, I'll schedule at 12:10 itself. Okay, if you've completed, you can leave the meeting now. Thank you. What about others still doing? Completed. Yeah. If you've completed, you can leave the meeting. Now, within half an hour, you have to complete the quiz, or else it will end. No one can access the quiz later on. So I've scheduled in that way. Please complete the quiz. Fine. Few students yet to complete. Make sure you're completing the quiz. Okay, I'll end the meeting. Make sure you're completing the quiz before 12:30. Fine. Thank you, ma'am.